Happy morning to everyone. Myself, Dr. Savita C, Associate Professor, Department of AI/ML, SSIT, Tumkur. Even before all of us started knowing what actually is AI, we all were very familiar in using AI. So now let's see how best we understand the different approaches to AI, then how any problem can be formulated and how to find the solution for the problems. So here let's look into a little incepts or to the concepts of artificial intelligence. To start with, we'll see like what are the different approaches in which we can know or try to know the AI. Basically, there are 4 different approaches: thinking humanly, thinking rationally, then acting humanly, acting rationally. These are the 4 important approaches in which we look into any of the different AIs in the present world. So, thinking humanly is machines which act like as though they are having minds to think like a human. Then thinking rationally, with whatever the computational models we have today, we try to get the maximum usage of them. Then acting humanly is it's an art of creating machines that performs functions wherein that requires intelligence to move ahead. Then acting rationally is basically to design the intelligent agents. So these 4 approaches are the basic building blocks in understanding any of the AI. So we'll look into each of the approaches in detail. So how we formulate and what are the basics in which each of them will proceed. So coming to the first one, that is acting humanly, this is also known as the Turing approach. Here, an Alan Turing, a scientist somewhere in 1960s, he designed what is called a Turing test, wherein an individual was made to sit before a machine and he was to put forth certain questions through typing the questions to the system. And in query to those questions, the system at the other end was sending him the solutions. In the sense, it was also sending him the solutions or the queries answered for those questions through text images. And an individual who was asking the questions was not knowing was it an individual at the other end giving the solutions for his questions or is it a machine that is answering for him. So if any of the machines was able to pass through this Turing test, passing through the Turing test is the individual who was into put forthing the questions will not come to know whether it was a machine or an individual who was exactly answering his questions one after the other. So any system that passed this was like a machine that passed Turing test. So that Turing test requires 4 important concepts. One is the natural language processing, because an individual would communicate in English and the other end, the machine was also supposed to communicate back its answers through the English language itself. So natural language processing plays an important role. Then knowledge representation. In order to answer the queries for the questions put forth by that individual, it should have the knowledge about whatever that individual is asking. So that is knowledge representation, basically to store the information and also to hear whatever the other person is putting forth his queries. Then automated reasoning, because there is no one to say to the system like this is how it needs to answer. Autonomously it should decide upon by looking into the questions and then answer to individual's query. Now machine learning is basically to adapt itself to the different circumstances. So these 4 parameters are very much required in Turing test approach. And the next approach is thinking humanly. Thinking humanly is basically to get into the cognitive minds, wherein a working of human minds can be understood by cognition or cognitive science. That can happen through introspection. Introspection is basically how we as individuals try to answer for any of the questions. Similarly, as an individual, I know, like, to certain situations how I'll respond through my activities or actions. So that is through self introspection. And also there are many psychological experiments done to observe how a person in action behaves to different instincts or different scenarios. Now also through brain imaging. Brain imaging is observing the human brain in action. Maybe somebody who is acting very ferociously, if a brain imaging at that instant is done, thereby we know like how exactly the brain is working or how it is coordinating with the different instincts. And the next approach is thinking rationally, that is basically the laws of thought approach. So here syllogism is a basic structure through which different logical conclusions can be drawn. So coming to a good example, we have Socrates is a man, and also another statement, different logical statements are given. Maybe two logical statements are given. Looking into those two, a third one can be concluded to be true or false. This is what is the laws of thought approach, or through syllogism we are able to provide the logical answers for the queries. So we know Socrates is a man, Socrates is a man, and all men are mortal. Hence, by looking into those two approaches or those two logical statements, we can conclude Socrates is also mortal. So this is how thinking rationally or the laws of thought approach moves. Now, the last approach is acting rationally. Acting rationally is how a rational agent is going to approach to any of the problems. So we know, like, why we go for these AI systems is basically they are autonomous in behavior, in the sense even without we informing it to perform in a certain manner, looking into the situations, we want it to act by itself proactively. Right? So that is what is, it should operate autonomously. A good example is, suppose a robot is trained to help us in times of fire explosion or so. So in such situations, individual cannot go and inform the robot or that AI system to act in a certain manner. By looking into the scenario, by understanding that a fire has broken, it should act autonomously. So that is what is operate autonomously, and to operate autonomously, it should continuously perceive the environment, like what is happening around itself or what is happening in the environment in which it is made to act. Then it should persist over a long period of time. It's not like for a small duration it is going to do and then just keep quiet. It's not so. So it should do whatever the perseverance is there over a long period of time, maybe until its lifetime, doing the same job. So also whatever the environment in which today it is made to act, tomorrow the environment might change. So our AI system should be able to adapt themselves to the changing environment to pursue whatever the goal for which they have been built. So an AI agent is supposed to constantly perceive the environment. Through these sensors, it is going to capture the information from the environment, and it should act autonomously through the help of actuators. See, sensors could be like temperature sensors could be present, wherein looking into the range at which the temperature is raising, the AI would come to know like, yeah, it is beyond some specified level, some dangerous thing is happening. That is perceiving the environment through sensors, and now it should act itself. Yeah, maybe it is equipped to spray something, thereby it can douse the fire. So that is done through the actuators taking suitable actions. So basically these are the 4 different approaches in which any of the systems or any of the AI systems would be looked upon. Now we will look into the various foundations that are required to design, because AI requires a vast field to understand its behavior. So coming to the basic foundations, to start with, philosophy plays a very important role, wherein philosophy is a bridge between knowledge and action. What knowledge it is having and when to act upon those knowledge. Then, and it is very important to AI because whatever the action it takes for any of the situations perceiving the environment, a suitable reasoning need to be given. So how does a mind arises from physical brain? That is also one important thing needs to be understood in this foundation of AI. And how does this knowledge come from? So how AI gets the knowledge with whatever it is having, or how it can get update itself or get to know the new things. So how does whatever the knowledge it is having, how can that knowledge be put to action? That is one important concept in philosophy. Now we know like mathematics also play a vital role in any of these AI systems. So as we know, mathematics always starts with different algorithms. So algorithm is one good important combination in mathematics to reason out or to prove something properly. So it requires logical analysis as well as the computation of different theoretical concepts. Also, there is what is called incompleteness theorem, wherein we know like certain theorems are true. That is, we know like certain statements or logical statements are true, but in order to prove them that they are actually true, we may not have sufficient information. So during that uncertainty also, many a times we may have to go with this incompleteness theorem. Also, another important parameter is intractability. That is, as the complexity of the problem increases, the computation cost also increases, but there would be some proportion. As the complexity increases, the computation cost or the complexity increases proportionally. But there are certain situations wherein a little change in the complexity of the problem increases the complexity of the solution exponentially. Such problems we call them as intractable. Also, probability plays a very important role in this AI. Besides whatever the logic and computation we apply in this through mathematics, probability also plays a very vital role. The next, another important component is economics. Economics is not only like directly related to monetary aspects, it is also studying how the choices made by people affect the outcomes. So we say economics involves studying how people make choices that could lead to preferred outcomes. And in large economics or in large economies, the behavior of different individuals does not affect the main component. Whereas in small economies, the actions played by other players also affect the way I am going to behave, or the way AI is going to behave. Say for example, in small economies, say for example in autonomous driving. So whenever an autonomous vehicle is moving, see, along with the autonomous vehicle's knowledge about the lane, about the traffic, about the environment, also a very important parameter is how other people are moving around in that lane. So other people's action, their behavior certainly going to affect the way I am going to drive, or the way AI is going to drive. So this is what is small economies. Then another good or another important field here is the neuroscience. So neuroscience, as we know, it is basically the study of neurons or the nervous system. So how brain exactly processes the information, and the brain in action can be understood by EEG or electroencephalograph. Now, one more functional MRI also could give us like how exactly brain behaves under different conditions. So now we are familiar with this neuron system. We have the cell or the nucleus, we have the dendrites, then we have synapses and the axon terminals are the main components in any of the neurons or nerve cells. So here in this nervous system or neuroscience, it is basically how the information is perceived. So these dendrites are going to absorb the information, then the cell or the nucleus is going to perform the operations that is required for that information received from the dendrites, and what action need to be performed would be sent through synapses via the axon terminals. So this is how the nerve endings are connected throughout the brain, and nerve impulses are sent and suitable action would be taken. Maybe when some fire is there, I know like how I should take out my hand as I approach towards that fire. Similarly, even this nervous system, studying the nervous system helps in knowing how an individual behaved in such a or a specific manner. So, comparing the computational capability of a supercomputer, a regular computer and our brain, we have certain data that is available here. So, computational units that are required by supercomputer, personal computer, human brain. So, this is for a supercomputer, the computational units are 10 to the power CPUs and it requires 10 to the power of 12 transistors. Similarly, a personal computers, we know max of 4 CPUs and 10 to the power of 9 transistors. Similarly, human brain would compute using 10 to the power of 11 neurons. So these are some other additional information regarding the storage units, cycle time that is required to compute, then how many operations per second capable of performing. So supercomputer performs 10 to the power of 15 operations, personal computer 10 to the power of 10 operations, whereas human brain is much more powerful and it can perform up to 10 to the power of 17 operations per second, and how whatever the information that is stored can be updated. Similarly, we can look into memory updates. So neuroscience plays a very vital role. Then coming to another basic ingredient, that is the psychology. Psychology is mainly with respect to the cognition process, that is how a human brain perceives certain information and how it responded in a certain way. So cognitive psychology, wherein a brain is viewed as an information center which is going to store the information, and as and when it is required, the information would be processed and a suitable action would be performed. So here these approaches are required in designing most of the algorithms wherein it tries to mimic the human brain or human cognition. Now, along with all these things, there comes the ethical aspect. How ethically, because different individuals might respond to a similar situation in different way. So, which one is ethically good, right? So, ethical issues like there shouldn't be any bias in making any of the decisions. So, all these things are very much importantly need to be addressed when we are into the cognition. Then comes this control theory and cybernetics. So both are almost very closely related, or we can say like they are interdisciplinary. Then basically control theory focuses on optimizing the results, fine. Then cybernetics is comparing to the present state. So how far we are to reach the goal state, and as far as possible we need to reduce that difference between the present state and the goal state. In the sense, we need to achieve our goal quickly. Now, coming to the state of art, in the sense what all fields we employ our AI. So, to name a few, because we know like in most of the fields, in all of the fields whatever we are using today, we are using AI. Mainly robotic vehicles. So Stanley was the first autonomous vehicle which moved through the desert at 22 miles per hour, then finishing 132-mile course in one of the DARPA Grand Challenges, and actually it won that challenge. We know like speech recognition is very important. One good example it started with was a traveler calling United Airlines to book a ticket was able to finish it, the customer was able to finish his booking only through this speech processing. So autonomous planning and scheduling, even NASA's remote agent program is capable of scheduling the operations from the ground to a satellite that is launched. So that is autonomous planning, and we know like each day many of our mails get filled through spams. So spam fighting, in order to address spam issues we can use that. Then logistic planning. Early in 1991, during the Persian Gulf War crisis, so US forces initially deployed DART to address the logistic problem. So wherein iRobot was the corporation which sold our 2 million Roomba robotic vacuum cleaners. Initially it was for home use, but later it was also the main intention of it was to implement, to carry out the hazardous materials or clear any of the explosives that were laid down. Then machine translation is a very important field wherein a computer program automatically translates from any given language to other. So initially it was done for translation from Arabic to English, and one important thing that was observed was, even though many scientists were involved in a machine that could translate from Arabic to English, but none of those scientists actually knew the language Arabic. But yet they were able to design a machine which can understand Arabic, and then it was able to translate completely to English. So to name a few, these are some of the state-of-the-art technologies where we use our AI. There are multiple. So even in healthcare, automobile, finance, surveillance, social media, entertainment, then education, space exploration, and even in gaming, robotics, agriculture, and e-commerce. So now let's look into intelligent agents. So agent is something which is capable of perceiving in the environment, then it acts through the sensors, the information obtained through the sensors, and providing suitable actions, or providing what actions need to be done to control that environment through the actuators. So this is what we call an agent, which contains sensors wherein it continuously perceives through the environment, and then whatever suitable action is required to be made would be done with the help of actuators. So we'll look into one simple example wherein a vacuum cleaner word which is having two locations. A vacuum cleaner is placed in one of the locations. These two are the words A and B. The job assigned to it is it should clean the dirt that is there on the floor. As and when some dirt is there on the floor, it should suck. So here it should suck by cleaning that one, and after that it should move on to the other side, wherein if a dirt is there it would pick or wait for some time, and then again it moves to the other part of the word, because there are two words only here. This is one simple example. So this is how the percept sequence moves. So initially vacuum cleaner is in word A. Suppose it is clean. Yeah, now this is clean. Now it will move to the right. So action is, if this word A is clean, it should move to the other word to check upon if there is any dirt. So it would move to right. Now again, now it is there on the right side. Similarly, if a dirt appears over there, it sucks that one and waits for some time, then moves towards left. So this is how the movement of the vacuum cleaner happens. So we now look into the different kinds of environment. So kinds of environment are fully observable if I know like what all different aspects that are there in the environment. Unobservable, maybe certain situations are not clearly observable. Single agent, maybe a crossword, I don't need someone else to play with, I can start alone. Similarly, multi-agent, at least I need one of the other person. Then we have competitive, then cooperative. So competitive is like playing with the other. Then cooperative is a taxi driving, wherein, as we discussed before, in order to move properly in any of the traffic lanes, also the other person's mindset or the way the other persons are driving around really affects us. Deterministic is if I can predict all the happenings that are going to happen in the environment. So similarly we have episodic, so wherein instead of complete the sequences, episodes are going to be fixed for some duration, and each of the episodes would be recorded. And each episode would be viewed sequentially. Static is when the environment doesn't change. Then dynamic is the dynamics of the system or the dynamics of the environment keep changing. Good example is taxi driving. So with this, we know like what are the different approaches, what are the different foundations that are very much required in any of our AI systems, and one small example of a vacuum word. There is much more thing, and how to formulate the problem, what are the different steps we look for. We'll look forward those things in our next lectures. Thank you.